Roger, Mudfossil University, today on the hunt for atomic reality. Now, I am going to show you things. This is not speculation. I'm showing you things that need to be explained. Now, they may be what I'm saying they are, they may not be what I'm saying they are, but you can't explain it to me in any other way that I can think of unless you can think of something. So this is up to you to think of something. And I'm going to tell you why I'm making the statements I'm making, and you will see that I have supporting evidence. I can't see anybody that can fight against it. Now, everybody knows and understands in the atomic realm that there is the right-hand rule of spinning particles. And this is just understood because it's seen. Now, and the right-hand rule is seen right here in this spinning particle of light. This is after the accelerator, and you can see they're spread out down here and they compact up here. It's obviously slowing down. There is no question about that. It is obviously spinning to the right because it is drifting to the left. That means as it spins, it's not exactly as far at the same time, next, and it drifts to the left. So I'm showing expanded light. I'm showing contracting light, which means that it's compressing and therefore it's slowing down, exactly what I'm claiming. These particles are strobing. Now, I cannot account for that 100%, whether it's a camera strobe or the particle for some reason blinks on and off. But let's keep going forward. That I, again, cannot account for yet. So, but I do see blinking on and off, so let's take a look at that. We're going to talk about the Fraunhofer lines, because they're key to this whole thing. This is what really tipped me off what's going on. There's a rule of 8, and it's shown in resonance frequency experiments, and it's shown there's an S1 orbital stability, and then there's 8 other stable regions of the Fraunhofer lines, which are represented by the first lines that he discovered. There was like 9 solid lines. Then there was a whole batch of other lines. They found like a 2,500, 3,000, I don't know, something like that. But what they are is they are resonance frequency lines, and I show those, and I'm going to show them in a experiment. It shows them very clearly. Now, there's an S1 orbital, which is right around the core, and there's only 2 electrons allowed in there. And then you go up to the rule of 8, which goes into the secondary orbitals and up from there. And they have to stabilize at 8. That's their nature, to be as stable as they can be. And this is shown very clearly shortly. You're going to see this. Now, if the emission and the absorption lines are equal, which they are, it will spit out a frequency, and it will only absorb the same frequency. So this is very, very unusual. They are equal. That means, and it has to mean, in my opinion anyway, the electrons are not the same. All right? So, if it only spits out an exact same frequency every time from a certain type of molecule or atom, that means that that particular electron in that particular frequency being emitted is different. And there's 8 or 9 types, and I'm going to explain them, and I'm going to show them, and you're going to see them. Each electron type has a Fraunhofer main dark line, which corresponds to its angstrom unit resonance frequency. So blue is really short, and it has a very short distance angstrom unit away from the core. Then green is further out, red is less easily held and sort of drifts away easier. The blue ones, when you shake those babies out, they're flying, and that's what you see. The green was not so much as the blue, but still pretty hard impact, and the red, they sort of drift off easily. That's why they have the least impact. There's nothing here that doesn't make sense, and if somebody can come up with what makes sense, I want to see it. So let's go look at the resonance frequencies emitted by a perfectly simple experiment. I am going to make some allegations today, Roger, Mudfossil University, about the Fraunhofer lines and how it relates to atoms and the new Electron Flood Theory. And these 9 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to explain this in great detail and why this is so important. These are emission and absorption lines. That means these 9 lines are the main frequency lines that are emitted and absorbed. That's why they're so dark. And they were the first ones that Fraunhofer discovered. Then they found a whole ton of other ones because they have a different characteristic. They are products of different bonding. I am saying that these are the primary rule of 8, and I'm going to explain it in great detail. Go along. It's starting out 345 hertz, and what they did is they put salt on this table, and nothing happens until you get this exact frequency, and then you get this exact pattern. I am saying this is the S1 orbital just before it goes into the rule of 8, because at the S1 orbital, I'm saying this is the electron region, and this is of course the nucleus area, and that's all it has. Now we're going to go into the rule of 8. So as it's going along, you will see it will stabilize at 1033. It'll be an exact perfect pattern, and you're going to see the rule of 8 all over these things. And not only that, you're going to see a really superb pattern. You see that 3, 6, 8, then it goes to the 3, 6, 8 at 1820, and then they form around. If you look around, you're going to find 8 of them around the center. Then at 2041, you're going to see another 8 of them. 3, 6, 8. You see that all around the center. Then at the next one, 3240. Again, perfect pattern. 8. This is the rule of 8. Now we're getting up close to where we fill up all of our 8. So that was like 6 or 5 or whatever. So this is 3835. Another rule of 8 perfectly forming around there. Then it will go to 3975, another perfect rule of 8 surrounding it, very concise, very perfect. Then it goes to 4049, another perfect rule of 8. Now we hit the where it starts to go crazy. Look, see that? Did you see that? 4129, it's not really that stable. And that is what I'm saying is those 8 major. You see, so here we are at 4129. It's just leaving its stability zone, and it's going to hit 4129, and it just can't maintain. And you're going to see no more real concise rule of 8. Watch. See, boom, it does 2 things at once. 41, it locked in left, and it does this and does that. That is not a rule of 8. All right, you see that? And look at that pattern. Here and X is up here. I looked at this for a long time. I wondered, how the hell is that happening? And then up above it, it starts to restabilize here and there, but you're going to see this is all different. This is not consistent. This is not stable. This is not Fraunhofer. That's why. These are not stable resonances. They're acceptable, but these are nuclear isotopes. These are the things that are going to decay. And you saw it at 4129, I believe it was. It sank in and then it dropped off. You see, here we are at 4049. Now watch, we go from 4049 to 4129. Watch, it locks in and then it drops right off. Still the same, 4129. It couldn't stabilize at 4129, and this is when we're just walking outside of the realm of the 9 heavy bars in the Fraunhofer lines. So my conclusion is that every one of these particles is a bigger particle. They have to be. They can only be absorbed at a certain frequency and only emitted at a certain frequency. These particles, these different atoms and so forth, molecules, are made up of different electrons that are different lengths, different sizes. They have to be. They exist at these distances. It's like string theory. I'm starting to go with string theory based on the fact that there are resonance distances from the core in angstrom units away from the core are different distances. They have to be different particles. They have to be literally different particles. When one of them leaves, and it's one of them that's locked into one of these frequency zones, it has to be a rule of 8. And it cannot be stable unless it falls into that rule of 8. So once they leave that rule of 8 and you get into the isotope range, you can see where 4129, they were like half working and half not working. And after that, you had a lot of resonance interference. So that's not stability. That's stability. All right? If I could prove to you that that was that is light, would you call that a particle? If I could prove to you that that was light, would you agree that it has a polarity, a plus apparent energy and a negative apparent energy, and a spike up and down? Would you agree with that? If I could prove that that came from light and is a product of light, it is in fact light. Here's my proof. That is light from a red laser, just a regular pulsed red laser light. The particle is in the center. I'm calling it a particle. So you have seen what we started out with was light, and it was a wave just like this, only it didn't stretch. This wave is being stretched due to a venturi, which is an acceleration device, very common device, for fully understood. It atomizes gas and fluids. And I am saying that light appears to be a fluid of particles. Now, you see this coming down here? It's stretched and pulled that way wide open. Now that is the particle beam. That's all it is in this in the laser beam. Even though you see this big concussed wave, that's just everybody getting out of the way like a jet fighter going through the speed of sound. So this is the particle beam, and it stacks up back here, and you can see these are the particles. They are actually the little white particles. They have now displayed themselves because they own regions. The way those little particles are, they're tiny little unseen particles until they concuss with something. When they are shot through the air, or when they smash into a wall or into an object or into each other, they display themselves as whiteness. The smashier they get, the whiter they get. Now, that's getting smashed like crazy. That's what's called plasma. Those particles who want to reject each other, and they are forced now to hold onto each other's hands, literally snuggled up tight with them, pushing each other through this. When they get out of here, they explode away from each other and create these elegant little patterns called interference patterns. Well, they're actually repulsion patterns. This sets up a wave in the center, not a wave, but the particles are streaming through here, all negative, so you're setting up a negative bar. It creates a zone that pushes away here, and that creates a zone here that pushes back at it, pushes, and you get these particle arrays. They call them interference patterns because they think they're from waves and so forth. They're not from waves. These are particle beams spinning, and they spin, and that's what looks like a wave on the side. If you look at it, it would look like this. But if you looked at it on the end, it's spinning. Of course, it's spinning that direction. Now, this is all the white particles that are concussing in the air here, and this enormous wave back here is the reaction from this magnetic crushing. It's crushing negative to negative, crushing, and that creates this. This is what's called a reverse electromagnetic field. It's EMF, electromagnetic field, and it's reversed because this concussion of, you see this wave, here's what you got to take into account. This wave coming in here, you see these pulses, they're pretty solid, they're pretty good sized pulses, so you got a lot of power coming in from that wave coming in, smashing here, creating this enormous white radiation. Coming back, you see how many bars you have there? They're not the same power as these, but they are higher voltage. This is more power and lower voltage than this reverse wave, which is higher voltage and less power. Exactly what you get when you collapse an induced magnetic field, and it spikes back at up to 10 times or even more the applied voltage, depending upon the intensity of the collapse of the field. Now, I'm going to explain this a little further, but anybody that understands inductance, capacitance, and all that business in electronic circuitry understands that an inductor, what it does is electricity comes flying down here, and here's a choke. And usually it runs in a coil, and there's certain types of metals, and they build a field around there. So it comes in, it builds a field around it, just like this. The field is built. It pushes back against the incoming particles and just builds this huge field. When the field actually saturates, it can no longer support itself. It collapses. When it collapses, going back is this enormous, enormous field in reverse. I think I'm getting pretty close. Now, I've shown that light spins in a right-hand rule, and that's the particle. I believe it's not strobing the particle. I believe the particle just continues forward spinning like that in a right-hand spin. So this is the trail that it would have gone. It's gone. Just the particle is the thing that moves. Now, the right-hand rule means it spins this way. We've shown it in the particulate form where it has these black and white spots and these spikes sticking out, and I think it might be a torus. This is speculation, and I want to make a statement right now. Every time I present something, I get attacked. Oh, you don't have evidence for this. Oh, you shouldn't be talking about this. Well, what do? I don't have the evidence to. I can't prove this stuff. I'm showing you what I see. If you can show me what you people think is correct, but you can't. You're all speculating and guessing on your stuff. I'm showing you what I'm seeing, and I'm trying to account for it. Now, you account for it. That's all I'm asking. All right, so the particle spins. We've seen that in that blue spinning particle. I showed that. We've shown that it accelerates going into a venturi, and that is a venturi, and that is a venturi, which means that anything entering is going to have to accelerate to go through there. I also explained about inductance crushing a magnetic field and pushing back at least 10 times the applied voltage, which is nothing more than the particle coming in is being shot back out of there like a cannon. Now, so we're seeing this structure. Dark, light, light spacing up, black, light. What is that all about? Well, I started to think if the particle was spinning, which we know it spins. Now, does it spin inside of here? It appears to. Because, and I'm not even sure exactly how, and that's why I want people to look at this, because I don't have every single answer. I've got a lot of questions, really. Now, I'm saying this particle spins. So here's what I did. If you took a spinning little particle in here, and it spun with the right-hand rule now. So it's right-hand rule, spin, speed, power, shooting out bright power lights as it spins in with the right-hand rule. Now, as it comes out of here, it's going to be pushed back out because the field becomes crushed and collapses here. And as I told you, that's inductance, and it's reactance. Reactance means it pushes it back because of the crushing of the magnetic field and the explosive reverse magnetic field. I showed that with those huge lines of magnetic re-radiation as it went through the venturi. Exactly what we're talking about here. So, what happens? Right-hand rule, right-hand rule, right-hand rule, boom, it stops, still going to right-hand rule. It has to come back out of here. Now, it's getting pushed back out. Now it's in the left-hand rule because it's going this way. And the left hand is opposite. It's going this way and still spinning to the right. So now it's going counterclockwise according to the direction of its movement. So what does that mean? It's going to crush its own field. So it's still spinning clockwise but coming backwards. So it comes out, it comes out, it comes out, and it either comes off this way, it's going to come off of this way. So as it comes down around here, it's still spinning, 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 clockwise now. It's always going clockwise. As it comes in here, now it's getting crushed again, and it'll come in one direction and come back out the other direction. This I haven't worked out exactly, but it's basically this type of thing. It rounds this corner, is spread out wide capacitance, it crushes into inductance, and then it spins back out of here, the same thing in the other direction. And then it has to go back up in here. So then now you got another one going in here, it does the same thing back here. Now, that's apparently what is going on. I also thought maybe it would do this, just one little tiny spinning around, but I think it opens up in this form as it curves around, just to the capacitance of it. Now, all right, so that is the basic reason I believe we have dark, we have light, and we have these spikes, and I believe it's a torus, and I believe there's a choke, which is the inductive crushing nature of a choke coil. And that will always re-radiate backwards an enormous collapsing field because of the compression of the particles into each other. That's what's going on here. As that light enters here, spins, get away from me, get away. I can't. There's no place to go. I got to get too close. Well, when we come out of here, I'm going to push you away as hard as I can, and boom, they go. Now, whether that's the light or the dark or I don't know what. This is why I don't have the answers to this. I don't have equipment to do this stuff. We're just working on $50 here and $20 here, you know. This is not something that I should have to do in the first place. But, you know, it's an interest to me, and it's an interest to a bunch of people. So why don't somebody take an interest in it that should be taking an interest in it, instead of just saying, go away, leave us alone, we've already figured it out, which, you know, it's not figured out at all. There's so many unsolved things that I have perfectly, totally solved with electron flood. The corona, the heat of the corona on the sun, on the extreme outside of the corona, millions of degrees, and 6,000 on the surface, is due to the ether that's in space. It's due to these free-floating particles. I showed those free-floating particles in the light acceleration experiments. And I'm going to show it again. We're going to discuss it again, because I believe these can sit around and just sit around like a donut and be happy in the air, attached to water molecules, and then something comes along and bangs and it squirts them in and squirts them out and squirts them back and forth, and that's when they glow. That's all I can say. Okay, I've shown this in many, many, many videos, that these particles are the product of light from a red laser going through a venturi, coming out of the venturi, and reconstituting itself, stepping back down to its red frequency, and displaying these particles. Now, not only in red, this happens in green. But these are the green ones, exact same architecture, only they're further away from the accelerator because it's a more extreme frequency. It's a higher powered frequency. It cascades through the atmosphere further. Now, that on and off pulse is something that I think I might be getting pretty close to understanding. Now, I'm sure I'm going to go into a lot more detail in this same video, but the first, what you have to understand is light can accelerate. You can see it accelerating. It concusses, and these are particles. You can see them as particles. What I want you to be sure you understand is that light itself, these particles, are the exact same particles as these particles. No difference whatsoever. These are moving forward through space. These are just attached to water molecules and so forth in the atmosphere, just hanging around. They do not glow until they become concussed. And why are they concussed now and glowing just slightly, not a lot? They're glowing from this reverse electromagnetic field. That is why they are glowing. Anytime, and that's a concussion wave. It's just like a pressure wave, bam, against it, and it forces the, and I'm going to show you that now, what I think is happening inside the actual electron. And I say these are electrons. They're not photons, they're particles, and they are the same thing as electrons. They're the things that spin around in orbits of atoms. And they are so excited from the sun and luminous bodies that they shoot away from that body because they are thrown off it. And I show that as well in other experiments using tractor beam magnets. And they leave that as light particles, and they flow through space as those light particles, but they are dark in space. And I have heard people looking for dark matter. Okay, basically that's electron flood theory, and I think I've shown some pretty good evidence to support it. Now, could be wrong, but I would like to see somebody else try to prove that it's wrong. It exceeds any other theory that I can see. And the reason is there's no neutrons. The electrons appear to be locked in only at certain resonance frequencies. Now that's still a little bit of a mystery, but to me it indicates that they're different sizes. Not that they're different frequencies. I mean, it will relate to a different frequency, but they're physically different sizes. And there is 8 prominent ones in the 8 orbitals, and the 9th one is in the, the 8, the rule of 8, and the 9th one is down in the S1 orbital with the helium, helium and hydrogen stuff. Now, I can't prove any of this, and all I can do is get attacked by people. And, oh, you don't have the proof. Well, I don't have the proof. All I have is what I'm showing you. But what I'm showing you. You can't show me anything. You show me anything. Cern says, oh, look at these little squiggly lines. They don't mean much. They don't mean much. I'm explaining my squiggly lines exactly what they have been asking for. I'll show you what Cern asked for Higgs boson and what we got. You see this? Simulated. They don't even have this. They're looking for these Higgs bosons, which are a crash, and then little particle filaments, and then these round magnetic fields called Higgs bosons. These are the bosons, which is a charged particle carrying a field around it when it crashes into some denser space. And we did exactly that. You saw what Cern would like to see. Here's what we have. These are those little particle filaments. They're coming from Cherenkov radiation, which was plasma from that Venturi accelerator, which I've shown over and over and over. These are the tiny little filaments, which is called the bosons. They are charged particles carrying fields which display upon impact in another medium, which is the unrestricted space. That's what Cern is looking for. That's what we have. And guess what, Cern? We also have something else. And it is caused by this little white particle, which is, I believe, spinning backwards, where these are spinning to the right-hand rule. All right, you people over there at Cern, there's one of those. That's that white particle, and it impacted with a regular light particle, which was spinning in the correct manner, the right-hand rule. This is my assumption, and it spit out this. So we know now, not only is these light, this is light. Nobody can say it isn't. It came through the accelerator as light particles coming from a red laser. They came out the other side. They manifested themselves as these magnetic fields surrounding the particle flying at extreme speeds. And this one, I believe, is his back spinner, and it is reforming to form one of these, it appears, and it's bleeding off something. Now, I've always felt, and I'm certain of this, is that these particles are negative particles. Now, why are they negative? Maybe that's the negativity popping out of there, a little extra bit of negativity. Something is going on giving them some extra negative potential. And I'm not exactly certain of what it is, but I see something like this. Nobody can explain any of this stuff other than what I'm saying. Nobody can explain it. So if you can't explain it better than I explained it, then you're in trouble as far as I'm concerned. So Mudfossil University, this is where you want to go to find out reality, and come on up.